Hello Math 30-1. Today we're going to look at exponential functions. Now to start this off, I have a question for you based off the show The Walking Dead. Whether or not you solve it now or at the end of the lesson is up to you. But I still want you to think about it now and look at it and analyze what's happening to help you understand exponential functions, okay? Now, by tomorrow's class, I want you to try your best and see if you could come up with a solution to this. We're going to go over it a bit more in class. So here we go. In the show The Walking Dead, let's say one zombie bites and converts one person a day. Okay, so each zombie only bites one person and converts them each one today. So let's say the outbreak started in Atlanta. Now, if one zombie is infected on October 1st, okay, will the number of zombies overtake the population of Atlanta, which is around 4.75 million, by October 20th? Well, let's look at this here. If we have one zombie on day 1, day 2 we'll have how many? We have 2 zombies. Then they bite 1, so it doubles again. We're going to have 4 zombies, right? Because each of those bite 1, they make 2 more, so now we have 4. Then each of those 4 bite a zombie, so we have 4 more, then we're going to have 8 zombies. Then each of those 8 zombies bite a zombie, we're going to have 8 more, which gives us 16. And then from 16, we're going to go to 32. So every time we are doubling. We double, okay? So after every day, we double. I want you to think about that. Now, how long before the entire population, do you think, of the United States is infected? That population is around 313 million. So I want you to try your best to come up with an equation for this. Maybe put in your calculator or come up with ideas on how to solve it. So pause right now and see if you could create an equation based on what's happening. Think, we're doubling every time. Each day, we double. All right? So we're starting off with 1, and then we double every time. So pause and try and look at that. Okay, so let's take a look here. This here is an exponential function. We're going to try and discover what this value b does in the exponential function. Okay? So here, we first are going to have 2 to the power of x. Well, that means, if I look at it, 2 to the power of 1 is 2, 2 to the power of 2 is 4, then 2 to the power of 5 is going to be 32, right? Now, if I have a negative, when x is negative, like right here, 2 to the power of negative 4 is the same thing as 1 over 2 to the 4, which is 1 over 16. So it's quite a bit lower than 1. Now, does this ever hit 0? Let's try 2 to the negative 100. That's going to be 1 over 2 to the 100. 2 to the negative a billion. That's 1 over 2 to the a billion. So it gets very close to 0, but never quite hits it as far as we go this way. Now, let's take a look. If we're going up, look, 2 to the power of 1 is 2. 2 to the power of 2 is 4. And we just keep on going up that way. Okay? Let's take a look at the next one here. What happens if we have 1/2? B is 1/2 now. It starts looking like this. Well, here, if I said 1/2 to the negative 2, that is the same as 2 to the 2. Right? So 1/2 to the negative 2, there's negative 2. It's the same as 2 to the 2, which is 4. So then 1/2 to the 2 is the same as 1/4. Look how that works. So what happens? How are these related? How are they not? Let's take a look at the next one. When I have b is 10. My x-intercept, or my y-intercept for all of them is the same. But right here we have 10 to the power of 1. Well, that goes all the way up. It's going to just shoot up exponentially. Maybe that's why it's called exponential equations. Look at what goes here. This droops more and then goes up. It gets closer. Because 10 to the power of 1 is 10. 10 to the power of 2 is 100 already. Okay? Let's try the next one. 1 over 10. So look how it's related to this. And notice how it's getting closer. Everything is closer to my y-axis. Here, everything tries to move closer. Let's try and look at 16. 16 to the power of x. It gets a bit closer, and then closer. It's always closer to the y-axis, it seems like. Let's try 1 over 16. Very similar to 1 over 10. Next one, let's try 3 to the power of x. Now 1 over 3 to the power of x. Okay, so can you make up an idea of what b does? If b is between 0 and 1, what does the graph look like? When b is greater than 1, what does the graph look like? Okay? What is happening here? Okay, when b is 0 to 1 or greater than 1. All right? Now, how are they related to each other? I want you to think about that. All right? So what does the value b do? Okay, so now that we've done b, so pause, I want you to fill it out, write down what you think b does, and now we're going to look at a. What does the value a do? So here we go. We're starting off, my first graph is the same thing. We're looking at this a value. The x does not influence the a. So the a is multiplied by whatever this is. So I have y is equal to 2x. Let's take a look if I multiply that by 10. Okay? We are now going to multiply this. I'm going to make this a bit smaller and go this way, move in there, and move in here. Okay? So let's take a look at this. When we have 10. That's interesting. Let's take a look at when we're looking at 2. Goes right there. What is my y-intercept? Because that's going to say 2 to the power of 1 is going to be what? 2 to the power of 1 is 2. But then we have to multiply it by 10. That gives me 20. 2 to the power of 0 is 1. Multiplied by 10 is 10. So that's why my x-intercept is 10. And it's just increasing it faster. Okay? Let's take a look at 0.5. So if I have 1/2. Well, 2 to the power of 1 is 2 times 0.5 is 1. So that's interesting. If we zoomed in here, we have 1 is 1. So right there, right? Because 2 to the power of 1 is 2, then multiplied by 0.5 is going to be 1. All right, let's take a look at my next one here. We have 1 over 10. It gets farther away. And my x-intercept now, or my y-intercept is 1/10, and we're going farther away. Let's take a look at one more. We have 1 over 5. It's not quite as far away. What about 5? It's right there. My y-intercept is 5. Once again, there is no y-intercept on this. So what does this a value do? Okay? What does that a value do? Notice how these are increasing all at the same rate, aren't they? They increase kind of at the same rate. It's almost like they are shifted in a way. Let's take a look at if I have 1/2. Okay, and let's see what these do. I'm going to just take off all of these now. We're going to look at all the 1/2s. Okay, so there's the 1/2. So let's take a look at 1/2 and the 5. Same idea. Here, my y-intercept is still 10. So still give me my y-intercept. Okay? And I have this one here. So let's look at what they do. So y-intercepts is always what value? Okay? If we go down here, zoom in a bit, maybe we can find these y-intercepts. Interesting. The red is that one, 0.2. That looks like halfway. Okay? So there we go. Maybe now we've also figured out what A does. Write it down. Pause. See if you can figure out what that A does to the graph. So let's take a look here. We're going to skip now all the way to this table here and look at how this table here at the bottom and look at how we solve things. Okay? So let's take a look. It says y is equal to 2 to the x. So what is the domain of this function? Well, if we look back at those graphs, they just went forever up. For 2 to the x, they just went like this. Okay, so the domain is x is an element of all real numbers. What is the range of the functions? Well, my range, if we remember, I went over it, we cannot quite hit 0, could we? So my range is y must be greater than 0. Okay, y must be greater than 0. We're looking at y, so y is greater than 0, y is an element of all real numbers. Okay? What is the x-intercepts of the graph? Well, my x-intercepts, does it cross this line ever? No, there are none. The y-intercepts were always equal to 1. If we take a look at it here, my y-intercepts were always equal to 1. It never crossed the x-intercept. Y-intercept was always equal to 1. X went on forever, and that's it. Okay? So, what is the equation of the asymptote? Was that y is equal to 0, or was the x-axis? Okay, let's take a look at the next one. So if we're looking at the 1/2, these were the graphs going up like that. Okay? So, once again, x is an element of all real numbers. Y must be greater than 0. Okay? And x-intercepts, there were none. My y-intercept was always 1, or my a value. Sorry for the freezing. And my asymptote was always y is equal to 0. It's on that line, or the x-axis. So, 2 to the power of x is an example of a growth. Okay? This reminds us of our introduction question, doesn't it? It's always doubling, right? Now, 1 over 2 to the power of x is an example of a decay. We start off big and then we go down, right? This one is growing, so it's a decay. Okay? All right, if we continue, the next one here was to discover the value of b. But we kind of already did that. So we're just going to sum up everything that b does over here on this next part. Okay? So, graph the function of the calculator. So complete the following. So when y is equal to 3 to the power of x, the value of a is what? The value of a is 1. Value of b is 3. Okay? Now here, and the y-intercept is going to be 1. Okay? Here, we have the value of a is 2. The value of b is 3. Y-intercept is 2. And then here we're going to have 5, 3, 5. 0.5, 3, 0.5. So if you remember, because this is our initial at 0 time, or 0x, right? How much population do we have? 0.5, 5, 2, 1. So using that, what is going to be your a value maybe for our Walking Dead question? What is your b value for the Walking Dead question? See if you could use that to help you solve that question, okay? Now, what is the effect of the graph changing the a value? So what does the a value do? Well, my a value is my y-intercept. Okay? And it is a vertical stretch. About the y-axis, or about the x-axis. Okay? So it's a vertical stretch about the x-axis. Alright? So that's what my a value does. Because really, if I look at this, we're replacing y with, for this one here, 1 over 2y. That's that one. This one here is y is being replaced with 1 over 5y, right? So basically, we're just having vertical stretches. Okay? It kind of almost looks like sometimes we're shifting them a bit, doesn't it? Okay? Now, what transformations are associated with 2, 3, and 5? So let's take a look at this. 2, 3, and 5. Well, this is the same thing as y is equal to f of x. Y is equal to 2f of x. Here is y is equal to 5f of x. And this is y is equal to 0.5 f of x. So what's happening? We have vertical stretch. By a factor of, in 2, we're going by a factor of 2. In 3, we have a factor of 5, and in 4, we have a factor of 0.5. Whoops, sorry. Couldn't really see that. So we have a stretch by a factor of 2, 5, and 0.5. And this is all about the x, or about the x-axis, because it's vertical stretch. Okay? So what is the effect on the parameter of a in this graph? So what does that do? That gives us our vertical stretch, and it tells us our y-intercept. Okay? So when a is greater than 0, it's a vertical stretch and y-intercept. All right. So here's our little quick review. Okay? We have used information from the previous explorations to find out. The y-intercept is always my a value. There is no x-intercepts. Next one here, the x-axis is a asymptote. Asymptote. How do you spell that? T-O-T-E. And it's a horizontal. Okay? The domain is always, well, x is an element of all real numbers. My range is y must be greater than 0. Okay? For when a is greater than 0, when a is greater than 0, when b is negative 1, and b is greater than 1, the function represents a growth. Okay? Because, think of it, first thing I always look at is b. b is greater than 1, so it's going like this. A is greater than 0, it's going to continue going like this. It's a growth. Okay? When the function represents a decay. So when b is between 0 and 1, just go like that, is between, it's greater than 0, but between and less than 1, my function is going to be a decay. So b determines whether it's an increase or a decay. The next one says the value of b affects the steepness as the graph as x increases. When b is greater than 1, the curve increases sharply as b increases. Okay, when b is between 0 and 1, the curve as b decreases. Well, 1 over 4 and 1 over 8, this one here is going to fall faster, won't it? This one falls faster. So it's going to, the curve falls sharply as b decreases. So this is a decrease, so it falls. Okay, it's not 1 over b. This here is b, and this here is b. Okay? Now, the value of a affects the stretch of the turnip. So when a is greater than 1, is this an expansion or compression? Well, this is going to be an expansion. When a is between 0 and 1, this is going to be a compression. Okay? This is a vertical stretch. This is a vertical compression. The next one is when a is greater than 0, or when a is less than 0, there is a reflection in the x or y axis. Well, if a is less than 0, we're going to have a reflection in my x-axis, so it's going to go down, and that's just natural from our operations we did before. Now it says, describe how the graph of the second function compares to the graph of the first function. Well, we have, this is my original, this is my second. Well, let's take a look at this. We have y goes to 1 over 2y. So I have a vertical stretch. By a factor of 2. Okay, and that's about the x-axis. And then we also have x goes to x subtract 2. So this is second, right? Stinky rotten tomatoes. So then a shift of 2 units right. Okay, that's it. So the next one here, we go from this, and we have y plus 4, and then we have negative 2. Oh, we have a negative there. X subtract 5. But this negative's on the outside. Okay? It's never going to be on the inside, it's on the outside. So basically, we first do my x goes to x over 5. So that's 1 over 5x, right? So that's my stretch. So what does that mean? So this one right here is a horizontal stretched by a factor of 5. Okay? Now the next one here is we have also y goes to negative y, which means reflect in the x-axis. And we also have y goes to y plus 4, which is a shift 4 units down. Okay? There we go. Let's look at number 2. It says, explain the transformation of this graph here is reflected in the y-axis. Okay? Okay, explain using transformations why this graph is a reflection in the y-axis of this graph. Well, why? If I look at this here, we have 1 over 3 to the power of x is equal to 3 to the negative 1x, isn't it? Isn't that the same? Yeah. So basically, what we're saying is x got replaced with negative x. So that is why it's a reflection in the y-axis, because it's a horizontal reflection there. Because this is the same as this, therefore x really got replaced with negative x. So then 3 to the x went to 3 to the negative x, since this is the same as that. Therefore, x goes to negative x, and that is y. Okay? All right, last question. Sorry, this was a bit of a long one. Consider the functions of f of x, f to the power of x plus 2 subtract 6 without using a graphing calculator. Determine the domain and range of the function. So I look at this here, I went down 6. So normally, my range is y must be greater than 0, right? But here we're down 6. So y must be greater than negative 6, okay? And that is, we're looking at y such that y is greater than negative 6 and y is an element of all real numbers. Also, x is still just an element of all real numbers, okay? Now it says, what is the y-intercept of the function of the graph? So now we want to find the y-intercept, okay? So my y-intercept is when x is equal to 0. So I will have y is equal to 4 to the 0 plus 2 subtract 6. So that's 16 subtract 6, which will give me the same thing as 10. So 10 should equal to my y-intercept. Okay? See how that works? Because 0 will give me my intercept. Next one says the equation of any asymptote of the graph of the function. Okay, so what is the equation of the asymptote? Well, that is going to be at y is equal to negative 6. Because before 0, because we're adding 0. Now it's going to be negative 6 because we have negative 6 there. Okay, so it's always equal to this k value. That's it. Well, hopefully you understand this. If you can now, try and finish that Walking Dead question as we get back to it, and I want to talk to you about this more tomorrow. Good luck and see you tomorrow.